This video is brought to you by Sporlan, quality, integrity, and tradition. All right, we have a kitchen AC today. The customer's complaining that it's not working right. We're just doing a visual inspection, walking up on the unit right now, looking at the condenser. The inside condenser is very dirty. It just got done raining, so that's why there's that puddle right there. We come on over here. The outside, this condenser is a little bit dirty, but not too bad. What happens on these is these condensers are easy to see, so they get cleaned usually, and the inside ones, they kind of get forgotten about. So we're coming over here, nothing too crazy, but you know what? Perfect reason as to why I say don't wear headphones when you're doing service work on the roof. I can hear that this unit has a loose belt just by standing right here. Yep. So that guy's gonna have to be tightened up too. We're not here for that, but it's big picture kind of stuff here. So let me tighten up this other handle. I have like a pet peeve. The handles all have to be facing down. Let's open up the electrical control panel over here. Might as well open this guy up. I bet you anything it's gonna have a loose belt too. Yep. I don't know whether or not you guys can see it, but the belt's like kind of slapping around on there. So we definitely have a loose belt. Let's check the air filters. Looks like at some point in time, whether or not it's leaking right now, they had a plugged up condensate drain line. So we have a typical economizer assembly here. They have a filter changing company do their filters. Not in too bad a shape. That thing's got some grease on it, but can only do so much with these. So we need to get into the electrical section over here and see what's going on. So let's open this guy up right here. It's like the grease cleaners are leaving their stuff over here. So we have no call for cooling. Again, it's a mild day today. We have some weird weather here. So let's enter the menu. Let's go into, it's hard for you guys to see, but I'm going into the test mode, okay? I'll hit enter, and then we're gonna go down to cooling. Actually, I shouldn't have hit that. Let's change it up to a full call for cooling. Okay, so cooling full, enter. There we go. Now we have all compressors running. This one's running, this one's running. Okay, that's a good sign. Let's see what goes on over here. These guys and their grease things are annoying. We should have condenser fan motors. Looks like this is loose. Someone left this loose, but okay. Looks like we only have one condenser fan motor running at the moment, but these guys do have pressure controls. So what you can easily do, we can check voltage, but sometimes if they have bad fan motors, which we have no idea, you can usually just grab something. Yeah, I don't think that's gonna work. It's gonna say, grab something and spin it, but yeah, I don't think that's gonna work. I don't have anything long enough. So we'll have to get in here and check voltage, because I think those condenser fan motors, this guy, wow. I don't have gauges on this, but this guy just shut off on, I think, high pressure or thermal overload. This compressor's insanely hot, and it just shut off. So I suspect we're gonna have condenser fan motor problems, and we also need to pressure up on the unit to see what's going on. But let's go ahead and test the condenser fan motors. So this is all our condenser fan motors here, 1, 2, 3, and 4, all 4 of those relays. There's all my capacitors. If you look right here, there's a diagram drawn. Condenser fan motor 1, 2, and 4 were not running, and 3 was the only one running. Let's go back up here. Still nothing, still nothing, still nothing. So none of those are running. We need to get in here with a meter, and it sounds like that one's going off on high pressure too. So yeah, we're gonna have condenser fan motor problems here for sure. All right, we got condenser fan motor number 2, 201 volts, and it's not running. Let's go down to condenser fan motor number 1 right here. Now, I don't know what's gonna happen as these units stage off. So condenser fan motor number 1 has 208 volts and it's not running. So we need to check condenser fan motor number 4 now. So condenser fan motor number 4, 201 volts. So we have got 3 bad condenser fan motors. So let's go ahead and turn the power off. Wow, you can hear all these compressors going off on internal bypass or something. Now we don't know if that's the only problems, so I'm going to talk to the customer and we'll probably have to get some condenser fan motors up here. I should have them at my shop, so I'll make some phone calls right now. Let's just do a visual too. Check in here. Look at these relays are pretty burnt up too. Pretty bad. So we may talk about those, and then we should probably test the capacitors too. All right, condenser fan motor number 2, the capacitor's testing bad. That's should be a 10 microfarad capacitor, and we're testing at about 5.92, so that's not good. All right, the capacitor for condenser fan motor number 1 is also testing bad at 5.5 microfarads, so that's not good. The only motor that was running was condenser fan motor number 3, and that capacitor is testing bad. It's plus or minus 5%, so we're still below that. And condenser fan motor capacitor number 4 is also testing bad at 7 microfarads. So we definitely need new capacitors, but we need to jump up and see what the bearings are like on the motors too, because these motors are notorious for having bad bearings. This one, and this one were the one that I was suspecting being bad. This is the one that's still working. So I want to show you guys what's going on. So let's spin this one. Okay, you see how it freely spins, no issues. Okay, let's see this one. See how it stops? The bearings are bad in that. Let's do this one. Same thing, doesn't spin, bearings are bad. This one too. So this one, and this one all have bad bearings. You can clearly see that this one's still free spinning. No problem. So this is the good one. We'll still change the capacitor on this one, but these ones are gonna all get replaced, and I'll just replace the motors and blades. It's a lot faster and easier. So I've got someone coming with them right now, and then we'll get these things swapped out. I'll start pulling them out. I always carry some penetrating oil. This is a rust buster. Just a couple drops. Looks like I'm getting low, so I'm gonna have to bring some more, but a little bit goes a long way. So just put it on there and let it sit, and while I'm getting everything else ready, it'll start lubing up and breaking down that rust and, you know, grime or whatever that would make it difficult for that fan blade to come off. So it's the little thing. So it looks like I need to get a new bottle. Like I said, I'll have someone bring me some. All right, I ended up changing the 3 relays on the motors that I changed. I ended up changing all 4 capacitors. Now, unfortunately, well, I shouldn't say unfortunately. Let me say this. I appreciate the fact that Lennox supplied AMRAD capacitors. I really do like AMRAD. They are superior, but they are American made. So that's really cool, you know, that you actually get to see an American made product being put in the field. Now, those actually came OEM from Lennox, which is interesting. Unfortunately, I only had 3 of those because I only brought 3 motors. I had to grab another one, which is just a normal Mars capacitor, which is fine. They work the same. It's just, you know, you appreciate to be able to support American-made kind of stuff. So we're going to wire this one in. Actually, this one I just need to tighten them down, and then we'll fire this guy up and see how it operates. All right, we're going to go ahead and rinse this condenser. Even though it's cold and rainy today, it'll be hot and sunny tomorrow. So we're going to rinse this guy off with regular water first, get it nice and wet. And then we're going to put some of the Viper yellow venom pack, which is microchannel and aluminum safe on here. So we're doing a pre-rinse first, saturating the coil, giving a smooth surface for the coil cleaner to flow on, and then we'll go ahead and start applying the coil cleaner. All right, always try to get it from the inside out. The cool thing about the Lennox units is these panels come right off. So, and you can see that the microchannel allows for the water to go right through it. But you still want to get some coil cleaner on there when it's really, really impacted and dirty inside. Another thing that you want to work on is getting these little troughs. They'll have a lot of stuff build up right here, and then that'll prevent water when it rains from getting out of the condenser properly, and it just kind of builds up in the unit. So it's always best to give it a good cleaning on the inside too. It's kind of like a drain pan. See all that stuff coming out. Yellow venom pack. super awesome, does a great job. Keep in mind, that is pure concentrate. Used with the Viper foam gun, and the Viper foam gun is different than the other ones. The concentration and the dilution ratios are different. So it works better with their products, okay? That much cleaner right there will probably do this entire roof and then some, okay? You can get, it says 9 gallons out of that, okay? So understand, that is pure concentrate. So we're gonna use this guy. I'm gonna clean this unit, and then I have someone else here, and he's gonna clean the rest of the units too, but I'm gonna knock this one out first. When it comes to the Viper coil cleaner, the yellow stuff especially, what you wanna do is spray it on and let it sit. It's not gonna hurt anything, okay? The blue stuff, yeah, that can etch the coil and cause some damage, but look at how that stuff foams up. Just let it sit and let it break down the grease and do its magic, and then we'll rinse it off once we let it sit for about 5-6 minutes. Coming in here, doing an inspection on the drain pan. Don't really see any problems down in there. Don't see any big issues here. I don't see any oil or anything like that. We got the belt tensioned up like it should be. Now this blower assembly could use some love. It's dirty. We'll have to talk to him about that. That thing needs to be pulled and cleaned, but that's a minimum 2-person job. Pull this whole skid out. It slides out, but it's kind of a chore. Pulley seems okay. We're just letting the coil cleaner sit. We'll get ready here in just a minute to rinse it. But yeah, it's just sitting there, breaking everything down, get it all in here and stuff. Make sure it, you know, rubs off any oils and different things that we see in there. All right, now's the fun part. We're just kind of slowly moving along. It's not a race. Gonna let the water just work its way through the coil and blast out all the dirt. Just like nastiness all coming out of there. So just nice and slow all the way across. Trying to get as much of the mud and gunk and grease, because we are right next to exhaust fans, so these things get greased up. I'm surprised they're not greasier than they are. Sometimes it can get really, really bad where you got to do just tons of passes with the coil cleaner just to make sure. But oh yeah, the stuff coming out of there is pretty dirty. It's kind of hard to see, but I mean, even the areas that I've gone through, I'm hitting them with the water again and I see mud coming out. So it just takes a lot of time, a lot of patience. That's the thing about coil cleaning, is it really is not a race. You really just want to nice and slow and get it done right, so that way you don't got to keep going at it, you know. And clean is clean. I can't express that enough when I talk to people. When I tell someone to clean a coil, I want it clean. I don't want it to go back and, you know, still blow grease out of it. Like, let's go to town, let's do it right, and be done with it and move on. Look at the stuff just coming out of here, man. It's just coming out. All these big old chunks. I washed a bunch down there. But this, like I said, this inner condenser just always gets forgotten about. Look at how the watercolor will just change the mud. Just keep going at it. These microchannels are kind of funny how they'll store stuff. So you see how it looks like, oh yeah, it's nice and clean, you know, but when you go up and down, you'll see that color change. So we're going through and we're blowing out all the water from the condenser, because the microchannels, they hold water, so you want to blow them out, pat them out, do something like that to eliminate a giant bubble fest from turning on, and it can make the unit go off on high head pressure in really hot ambience. So we're just blowing it out, and then I'm rinsing the roof, getting all the stuff that I got out. And if you come over here, that way it doesn't suck back up, but all that dirt is from this condenser. All those chunks, all of it. So we're getting it all away from the ACs. This bag is so versatile, and I don't know the max weight limit, but I've got 3 condenser fan motors in there, hook up a rope to it. It doesn't seem to mind that much weight at all. Great all-together bag. I shove so much stuff in there, and it saves me time when I'm trying to get up onto the roof. All right, we are up and running. Every condenser fan motor is working now. We're in full cool right now, just checking everything out, making sure the unit's working properly, but I think we're gonna be happy campers now, so we're just gonna watch it for a little bit longer and see how it's operating. All right, this unit is working. We are no longer going off on high pressure. Now, I don't really see the point in putting service gauges on this guy because it's kicking butt and it's like 55 degrees outside right now. Maybe 50. It's super cold. So I don't really see any other issues with this guy. Don't see a reason to have to probe up on it really. We clean the unit up. When we get some warm days, we can come back out and go through everything. But I mean, I really don't. It's not going off on high pressure anymore, so I don't see the need. So that's it on this one. We still have to get them VFD for that one right there. So open this one up and I noticed that the VFD is blown apart again. I shouldn't say again. I mean, I had a problem with the VFD many years ago. But look at this. The whole thing, the capacitor's got a hole in it. Arc flash like singed the side of the compressor. This thing had an explosion there. So I think what we're gonna do right now, because this unit is powered off, is go ahead and bypass the drive temporarily, get the unit back up and running, and then we can further troubleshoot. We'll have to order a new drive kit for it, but at least we can get it running for now, and then we will, hopefully it'll be a warmer day when we come back to replace this drive, and then we can go through this unit and test all the functions and everything. All right, I got the drive bypassed. It's just gonna, the blower motor's just gonna run 24/7 for now, temporarily. We need to open up indoor blower section, make sure it's running in the right direction. 1, 2, 3, please don't blow up. Oh, this thing's hard to turn on. There we go. It's running. It's going in the right direction. Belt's tight because we tightened it up. And then we're waiting for this guy to turn on. So we're gonna talk to the customer. Maybe we'll put a, I don't know what the problem is. I mean, the last failure happened probably about 3 years ago, I think, and the drive failed, but I don't think it blew apart. You guys may remember, I don't know. I don't think it blew apart though. I think that there was an intermittent fault in the drive or something. And I remember talking to tech support. We ended up having to change the drive and the relay, I think. Interestingly enough, that relay's burnt, so when we do change the drive, we'll make sure we get another one. But maybe I'll talk to the customer about letting me put a phase monitor on this guy. I don't know what kind of voltage protection that drive has built into it, if any, I don't know. Fired this one up in cooling. This motor sounds like it's a helicopter. This one's spinning slow. It's like capacitor motor failure heaven here. This one is spinning slow. This one is spinning normal speed. We better test voltage and then check the capacitors. We might have to change motors on this guy too. So check this out. All the nuts are missing off the bracket. There's only one nut right there. This one's missing. This fan shroud is hitting the fan blade. What the heck, man? So we're gonna pull this off, and then first we gotta turn off main power. Then we're gonna pull this off and then look and see if this is something we can repair. I don't know if I have nuts for this or not. All right, I don't feel like there's anything wrong with the motor. We found all the nuts down in the bottom. They just had vibrated off. So I don't know if someone left them off or what, but I tightened them all back on. What it was hitting was this shroud right here. It's not gonna hit anymore. There's a little bit of damage to the blade, so we'll have to see how bad that is. We're currently checking all the capacitors too, because a bunch of these motors were spinning slow. We're gonna spin them to see if the bearings are good. Maybe we can get away with changing capacitors on these ones. This one is right at the threshold of being bad. That one is bad. That one is bad. That one is bad. Every one of these caps is bad. So we're going down to grab some right now. All right, we replaced all the capacitors and the condenser fan motors are all moving at full speed now. Yeah, they're kicking butt. No, they're not. Wait, yeah they are. Yeah, I don't know, that one feels weird. This one's not vibrating as bad anymore. The vibration's gone from this one. Then we put all the brackets on, but no, this one's bad. This one's still like, I don't know, it's running slow or something. We'll have to come back and address that. But let's see what the voltage is for this place, because why are we losing so many caps and the VFD? 200 volts, 201, 201. I mean, it's okay, but it's right at the threshold of being pretty darn low for things like a VFD. Yeah, and on a hot day, I imagine that voltage is going to drop even lower. So we're going to put a phase monitor on this unit, I think. I'll have to look and see what the current ratings are of a phase monitor though, because like I don't know if I can put one on the whole unit or just put it on the VFD. I'll have to do some research on that. I was thinking it's just like one of the ICM 4 whatever things, but I don't know. I don't know if those can handle all the current of the entire unit. So the unit's up and running. We're definitely gonna have to come back with some condenser fan motors though. It's like 5 o'clock, so can't be spending too much more time here, but we'll dig into it when we change that VFD too. All right, it is another day and we are back. So this is the unit that had the bad VFD. I had bypassed it, did look into the VFD, and it is out of stock with it back ordered with no end in sight. So this is going to be a permanent but temporary bypass for now. We're just going to leave it like it is probably. But I need to go ahead and do some testing on the motor. I want to meg out the motor, see if there's anything going on with the motor, and then we got to look into the other condenser fan motors that were problematic on this unit. So we already changed all the capacitors. So I'm in the test function right now. It's going to be hard for you guys to see, but I went into test, and condenser fan motor number 1, I have it on right now, FN1 on it says. So we're just going to go through and test each condenser fan motor, find the bad ones. I did bring some more with me, motors, blades, so we'll go through it all. All right, I'm already seeing something, so let's check this out. So we have it fan 1 on, okay? I know it's hard to see, but we're in test mode. We went through service test, fan 1, we have it on. So let's go ahead and test the unit voltage. The unit voltage for this guy is 202 volts. Now, granted, that is low because, you know, but it's within operating range. 203, 203, okay? So we have 3-phase, about 202, 203. Now, we have one condenser fan motor on, fan motor number 1, which is this top relay, okay? So what we're gonna do is we're gonna probe up on fan motor number 1. Let's go into here. Oops. We'll get the probes on this. Into here, and there we go. All right. Actually, no, it was weird. I got a weird reading a minute ago, but we're delivering 208 or 202 volts. So we're good there. So we actually are good, but what's interesting is if we come over here, this fan motor's not running. Is it? I don't know. It's running right. I don't know. It felt like it was kind of low, but it's moving. Yeah, and I don't feel any weird vibrations. So remember, this one of these was vibrating really bad because this is the one that all the screws were out, but it seems like it's running okay. Let's go ahead and get a current test on it. So we come over here, and we should be able to grab one of these gray wires, I would think. Yeah, I'm gonna have to get on that to figure out which one to grab. So we're allowed to run 2 amps. We're right at 1.8. So we're good on current, and this motor feels like it's working properly. So we're good on this one. Let's move on to the next motor. All right. This is motor number 2. It's running 1.8. About the same, so that feels right. Let's move on to the next ones. All right. This one's right about 1.82, which is interesting because these were running slow the other day, but maybe it was just an issue. They were the capacitors. I mean, we changed the capacitors, but I felt like they were still running slow. Interesting. All right, and this one's running fine too. It's a little bit higher on current, but it's still under where it's supposed to be. That's interesting. You know what though? This one, you guys may not be able to hear it. I can hear the bearings going out on the motor. Pulled the blower assembly out. Motor's extremely hot, but it has been running consistently. But yeah, it's like extremely hot, almost too hot. Open up the electrical section in here, and honestly, this guy looks like it's been replaced before, because electrical tape isn't typically factory like that, and it's really crispy, like it's been overheating in here. So we're gonna open this up, disconnect the wiring, and yeah, it looks like maybe something had burnt in the previous history on this guy, but there's no burn marks on here, so it's almost like someone's changed a motor. And we're gonna meg this guy out. Got the insulation tester hooked up, isolated the other lines. This is a 208 volt motor. I'm gonna test it at 500 volts. So we're set up, insulation test, greater than 550 mega ohms. So the motor tests okay. We need to get an amp clamp on this guy and see how it's running, make sure it's not overamping, because it's extremely hot, like insanely hot. Like there's something wrong in there. Another thing that we should do, spin it when we're doing the test. I had a buddy show me that he had a motor that was grounding out when it was spinning. My buddy Michael showed me this. It was a really interesting video he sent me. So no, not the case. Okay. Well, we're gonna put this guy back together and test current on it. Interesting, I was looking at the notes from the balance company, and it says that fan RPMs are 893. That seems extremely low. And it says 8.9 amps is what they were running. We're allowed to run like 9 amps on this guy. But I'm curious, because this unit has a VFD on it normally. So like, how are they, I wonder if they were compensating for the slowing down and speeding up. Well, we'll find out right now. With the pulley set up on here, when I'm running at full speed, because the VFD is bypassed, we'll see if the motor's overamping. All right, I mean, it's right there, 8.8 amps. So it's not overamping on the motor. All right, that's interesting. So we ended up coming over here, and we ended up changing 2 fan blades, because number one, I showed that when we were first here that there was screws missing out of this one, or nuts missing off this one, off the bracket. So we replaced those because I found them in the bottom of the unit, but I also found an extra nut, and we actually found that this one was missing some too. So we ended up changing both this fan blade and this fan blade, but we haven't changed the motors yet, because both the fan blades were damaged. They had dents and stuff in them, and they'd been rubbing on the side of the unit. So we're gonna turn this guy back on, put it into test mode, and see how it does again. All right, and this thing is much quieter with all the fan motor and fan blades replaced. This one's not vibrating anymore. Nice and smooth. The airflow is equal coming out of all the fan blades and fan motors. So we changed all the capacitors, and for the life of me, I can't remember if they were spinning slow after the capacitors. I guess I can review the video footage, but you guys may already know that. I have this guy in a full call for cool for test. It's funny because it's actually thermostat's telling it to turn the heat on, but we're just running a full call for cool just to see how everything's operating. Again, it's super cold outside, so yeah, crazy. I just can't believe the California weather. It's so cold outside, this guy won't even stay in test mode. It just keeps going off on alarm and turning itself off. It's kind of funny. It's probably freeze stats or something like that. But yeah, the heat fired back up because that's what it's calling for right now. I mean, I'm not seeing anything crazy. I'm contemplating putting in a phase monitor, like I said, just to monitor the voltages, even for a while, just to set some limits and come back and see if we're tripping on anything. I'm suspecting some sort of a power issue causing the drive to explode, the capacitors to fail so soon, you know, so it's gonna be a low voltage issue or something like that. So I'm gonna go down to the van and get the I have one of the ICM phase monitors. I'm gonna throw it in this unit, and just that way we can get some kind of data logging history because it'll stave all the faults and everything. All right, what we ended up doing was installing a blower contactor. I did some research and I found the wires to power the contactor. So we set it up so that way it's going to run on a contactor temporarily, and I installed a phase monitor. It's going to look at the voltage, the phase balance, and all that good stuff. And we set the parameters up so that way if we come back, we can look at the history and see what's been happening with this unit. Now, we're not controlling the unit with the phase monitor. We were going to think about doing that, but it's pretty complicated what you have to do. I'm pretty confident that we can get into the Prodigy controller and probably set up a phase monitor in there, but I didn't want to have to go too complicated changing the unit up, when in reality, we're going to be coming back with a VFD, and this is literally just here to let us know what's going on, because something was causing that VFD to consistently fail. Now, it could just be that it's in crappy conditions, it was full of dirt, but there's a VFD in that unit over there and it's not an issue. So why this unit? So that's why we installed the phase monitor, just to let us know what's going on. Yeah, and that's it. So this unit is operational until we can get a new VFD for it. But again, they're back ordered and we have no end in sight as to when it's going to be in stock. So this unit is good for now. We're going to wrap this up and just tell them to keep an eye on it, and we'll return when we get the VFD. I have said it so many times, and I keep saying it again, we really have the ability to find so much work on these commercial rooftops and even residential if we just keep our eyes and ears open, listening to the sounds, you know, the smells, the vibration, the heat. You know, you just use your senses and you're able to find things. So I'm able to be on this roof and notice that I can hear belts squeaking. I open up other panels, even though that's not what I'm there to work on. I just kind of poke my nose around. I'm being aware of the situation, and I'm bringing all the information to the customer's attention. So they called me about their kitchen AC. They didn't even know that their entire dining room AC was down. Now, I didn't show it on the video, but that VFD that blew apart, it tripped the main breaker downstairs. So the whole unit was down. And I was able to generate an entire PM, basically, right? I cleaned all the coils, tightened all the belts, brought another person with me, changed capacitors and multiple ACs, found another VFD that was bad, multiple fan motors, fan blades. We were able to go to town on this place, and we didn't do anything wrong. We didn't sell them anything that they didn't need. They don't do a routine maintenance here, so this is kind of how we do it. It's more of a reactive maintenance. When we're there, we just look around, open our eyes, generate more work by finding problems before it generates a service call for them, okay? So being thorough. Now, with this restaurant, you know, obviously I mentioned that we've changed that VFD before. That concerns me. So I installed a phase monitor that has a memory in it. When I do go back to change the VFD, I will have a history of errors inside that phase monitor, and or if the customer wants me to go out preventatively before then, okay? Now, we did order the VFD, but for now, we installed the contactor that will run the unit until we get it back in stock. And then, like I said, I have that phase monitor, and it'll save all the errors in there. So when I go back the next time, I go up there and I look at the roof, and I notice that it has multiple low voltage issues. Okay, bam, now I have power to give them information to tell them to call an electrician, right? So that way maybe we can solve this problem, because again, this is the multiple failures of VFDs on this unit that's concerning me. Again, I'm being aware of what's going on. I'm remembering things, looking at service history, okay? So we're not just going in here blind, not paying attention to anything and just, you know, jumping into things. We're kind of being observant, you know, looking at the surroundings, looking at the service history, and we're able to come up with, you know, potential problems that we can try to solve. So it's more than just going out and just changing motors and measuring voltages. You know, it's having situational awareness, paying attention, being genuinely concerned about the customer. Now, I genuinely am concerned, okay? I want this customer to succeed. I want this customer to be profitable and to be successful, because equipment breaks. It's inevitable. So if I can keep this customer happy and find problems before they notice them, I can, you know, prevent breakdowns that could cause loss of customers to them. and it makes them more successful, and therefore I am going to continue to be successful, because if I keep the customer happy and they like my service, they continue to use me for years and years and years to come. Okay, it's inevitable that equipment's gonna break. So if I can stay on the customer's good side and just be a genuine, trustworthy service company, you know, then I hope that they continue to call me for years and years to come. Okay, so it's all about the big picture, thinking about that, taking care of the customer, treating them as your own, and obviously doing what they want. Some customers don't want you to open up their equipment if you're not there to fix it. Okay, then we need to observe those requests from the customer. Now, this particular one appreciates the fact that I go above and beyond, and they know, and this is a normal thing. We go out there to fix you know, a reach-in cooler, and I tell all my employees, hey, do me a favor, run up onto the roof. They have a lot of Linux package units. Go look at the codes, look at the service history, or look at the history in the units. Is there any low pressure, high pressure codes? How do the condensers look? And then we report that information to management or the higher ups above them and ask them, would you like us to service this equipment? We'll take pictures, we'll document it, send it to them. And they say, no, you know what? We don't want to do anything else. Okay, that's fine. But we're at least arming them with all the information, the pictures, and then just, you know, letting them make the decisions on whether or not they want to fix it, all right? I really appreciate you guys taking the time to watch this video till the end. It's amazing, all the support, the feedback that I get from you guys. If you haven't already, please consider checking out my website, hvacrvideos.com. We have merchandise. We got these hats, shirts, a couple other shirt designs, sweaters, beanies, all that good stuff on there. It's a great way to support the channel. There's also links in the show notes of this video. There's affiliate links for TrueTechTools.com, which if you click one of those links and you purchase something from their website, I get a small commission. Also, you can use my offer code with TrueTechTools.com, big picture, one word. You get an 8% discount on checkout. And then, like I said, there's other links inside there. You click on PayPal, YouTube channel memberships, Patreon, just different ways to support the channel, okay? Do me a favor, leave me some comments, leave me some feedback of what you think in the video down in the show notes. And yeah, that is pretty much it. I really appreciate you all, and we will catch you on the next one, okay?